Alright, so let's talk about these two questions. 157, read and characters given read 4, and its follow-up, 158, which is the read method going to be called for multiple times. The difference is that 157 is stateless. So when you call read for multiple times, they're going to behave independently. But for 158, when you make consecutive read calls, the second call is going to be able to resume from the termination point from the first call. So there should be some state being saved after each call, so that the next time you call it, it's going to be able to pick up from that point. So that's the difference. So let's read through the what's been given to us. It's quite long question. I'm going to try to read through this very quickly. So we have a file. Assume that we can only read using a given method call. It's a read 4. And we need to build on a more general read method on top of that. So the read 4 is reading 4 consecutive characters from the file. There might be a lot of reasons for that. I guess if you get this question, you might be interviewing for some kind of infrastructure role or networking role when the stuff is fixed lens for the operations. I just disclaimer, I don't have any expertise in that area, so I might be totally wrong. But what I imagine is that maybe like the CPU's is 32 bits, so the old times the CPU is 32 bits, and now it's 64. But for consecutive character, if they 8 bits per character, the 4 multiplied by 32 by 8 is 32. That might be just the amount of stuff that the CPU can efficiently execute in one run. So that's why they provide you this lower level API to read 4 consecutive characters from the file. And since it's a fixed length, but you might want to just get 3 or any arbitrary number of characters. So you want to build on top of this lower level API for a more general usage API calls read. I guess that's the purpose for this question. So we need to. So when we call this read 4 and provide it with a buffer, it will put the put the characters read onto the buffer and also let us know how many valid actual characters are there. So it's overriding the existing values in the buffer, and it's actually telling us from what point are the new read stuff. If we have old stuff at the end of the buffer, that will not be removed. This return value is telling us from that point and on, the stuff on the buffer is going to be obsolete. So that's this read 4 thing. And here it just explains that if the file is ABCDEFG towards K, when we call this read 4, provided with this buffer of size 4, when we call it the first time, it's going to put ABCD 4 characters onto our buffer, that we provided to it. And it's going to return 4, telling us the 4 characters, all 4 characters on the buffer now are read from the file. And if we call it the second time, read 4, the second time, it's going to replace the ABCD, the old values on our buffer with EFGH. And it's also telling us 4, so the 4 characters here are valid. And in the third call, it will return 3. And on the buffer, I don't think this is the case. When it might not be the case, I'm not sure, but it's telling us 3. I think there might be an edge here after this, but things it's telling us 3, so we should only grab the first 3 things from our buffer. I might need to test this, but from what I tested earlier, I think it's actually just replacing the first 3 things on our location on our buffer to be the remainder 3 characters, and it's telling us 3 so that we don't treat the following 1 character that's potentially BH as the Let me actually just quickly test it. So let's say that example will be just this. I'm just curious if their documentation problem description is right or not. Let's say that we don't care about this number, we just want some outputs. Just do this for 3 times. So let's see what it outputs actually. Yeah, so the documentation is problematic. In the first call, it's putting ABCD onto our buffer. The buffer is initially to be a length 4 character buffer, and when we call it for the first time, it's indeed ABCD. The second time, you replace ABCD with EFGH. But the third time we call it, it's IJKH. So it replaced the first 3 things with the new read characters from the file. But the very last one, it's still the old one. But it tells us the 3, so only the first 3 characters are newly read. We should discard the very last one. But this is not right. Okay, let's get rid of that. Here is some description of how the read method we implement should behave. So we'll be asked about the read like n characters from the file, and the another buffer. This should be named something other than the buff. Otherwise, they will treat these 2 things as the same thing, but it's not. So this is the final target for all the n characters should go to. So this should be at least the size of n. But that buffer is just for demonstration of read 4. That buffer has size 4. So I just don't like the question's description. It's just misleading, quite misleading. So this is the definition for read. Provide with enough capacity buffer and a size n, it should return the first n characters from the file, so that we basically do a transfer. We keep putting 4 and 4, 4 and 4 new characters onto the smaller buffer and transfer that characters onto this target buffer, and that's pretty much the what this read should do. We should handle 2 things, right? One is when the file ends before n. Or the other case is that we reach the n characters, so we terminate the file. We don't need to add any more since n. So there's just 2 cases to handle. Otherwise, we just keep reading, getting 4 and 4 and 4 new characters and putting that onto this buff. That's what the read should do. I think we don't need to go about to work through these 3 examples. It's you get the idea about this question. So here are some notes. We shouldn't access the file. We can only use read4 and use that to build out the read more generalized read function. And that's for this question. The read will be only called once, so that we don't need to store where we end in the file. So that's for this question. The follow-up should would drop this restriction, so it becomes a little bit harder. And we can assume that the destination buffer that's being provided to us is going to be large enough to hold all the characters. Yeah, so let's start coding this. Let's just use internal buffer of size 4 and use that as the transition to keep fetching onto the internal buffer of size 4 and decide how many we're gonna continue to transfer that onto the destination buffer, and just terminate when we reach the end of file or reach the number of required characters. So that's pretty much it. the two confusing part is this, and also the fact that this buffer and this buffer use the same variable names, but in fact that they are not the same. So what we're gonna do is just gonna keep track of the number of characters we have read from the file, and we use a flag to determine whether we reach the end of the file or not. So before either of those things happen, so num_read is less than n, or not EOF, end of file. If none of those two condition meets, we should continue to replenish our own buffer and transfer the stuff onto the target buffer. So we call this read4 and provide it with our own buffer of size 4 here. And then we determine the delta, that's the number of new characters we should transform onto the destination buffer, which is going to be a minimum between the current read and the required. So that's just how much we can give, and the maximum that we can give, and this is the you know, if it's a smaller than 4 or smaller than the current one we read, we don't want to go above n. That's just a quick explanation why it's n minus num read. And so then we just transform the delta onto the buffer. We increment the counter for number of characters we have read by the delta as well. And the EOF is signified when the current read is less than 4. So when we couldn't read a full character, that means that we reached the end of the file. And what we need to return, the number of actual character read. So it could be two things, either n, if we actually successfully read n characters before end of file. Otherwise, if we meet end of file before we read all the characters, we're going to return however that we've been calculating. So that's we return num read. So this should be the code for this question. Jeez, this is slow today. I have an arrow. I have an arrow. So it's end. Yeah. So the criterion is end. Yeah. Either one of this will violate. We should exit. I'm sorry about this. So let's look at the follow-up question then. The follow-up question, what's the difference? This API description part is the same about read4. So it's the same problem with the IJK there. And then more on read, this is going to be the place where the difference is going to be. So let's look at the example actually. So when we initialize this object and call read1, the file is ABC, so it's going to return, it's going to put a single A to the buffer. Then we provide another buffer, or we treat this thing as the new buffer. And when we call it with 2, it should pick up with where we ended last time. So the stuff that's being read by 2 characters is going to be BC. So now the buffer should be BC. And if we call another one, since we already run out of the file, end of the file, well, the new buffer should be empty, and they should be 0. So that's what it means by multiple calls. So that after the first call, even though we actually using read4, we pretty much read ABC there. We're gonna remember we only used A. so that next time that we call this read method, we're gonna pick up from BC. So yeah, so that's pretty much the only difference. So as with the so the difference compared with this original, the first question is going to be, we gonna keep the buffer. We don't want to lose it when we second time call read, and we're gonna keep track of some statistic about the characters on the buffer, on our own internal buffer. To be specific, it's going to be the number of characters, valid characters on the buffer, and the number of characters we have already used in the read call, so that the next time we can just resume from the next available character in our own buffer. So that's just going to be the difference. It's not too difficult, I guess. It's just that you have to realize that you have to be able to resume from the previous call, and the way you do that is just memorizing memorize the buffer and the statistics about the usage situation. So for this, in the initializer. In the constructor, we're gonna initialize the buffer to be a capacity 4 string character buffer, and now our initial status is that the number of characters being used from this buffer is 0. The number of characters that we actually fetched onto the buffer is also 0 in the beginning. And we also transfer that flag, end of file flag, towards the object itself, so that during multiple calls we can always find whether we reached end file or not. So that's these 4 things. We pretty much transfer the EOF and buff4 from the body part towards stick that towards the object, so that for multiple calls you can resume. And these 2 things are gonna help us to resume from the correct characters. And then I'm just gonna copy this and paste over and do some modification to it. So did I miss one line? Yeah, I missed this line. So the termination is still the same, whether we have read enough characters or we reach the end of file. Otherwise, so we're gonna have a condition to do a new fetch. If we don't need to do new fetch, we're gonna put on the transfer the stuff onto the buffer. And when should we do a new read? That's when we used up all the characters we have read. So that's when these 2 things become equal. So when this is the case, we just basically refresh this with the read4. And provide it with our own buffer. And we reset the statistics. I think a little bit tricky here is the EOF determination. So we will only flag it when we couldn't read anything. So because if we read less than 4, but in the same time we only use 2 of those, we still have 1 that we can supply to the buff in the next read call. So now the flag should only be turned on when the new read is actually 0. So this is slightly different than how we flag things here. that's the difference is just that because that we have to be absolutely sure that we want to flag this. You know, if even if we read 3, we still have 1 that we can use. We don't want to flag that. So that's this, and then is so we basically removed the read onto here and have some statistical reset here to go with that. Otherwise, we do the same old thing to calculating the delta, and the delta is going to be for consecutive call that the current use can be smaller than the current read, and we want to use up the remainder, so that's the difference here. And then the second part is still the same. We don't need to modify that. And transfer stuff onto the buffer. Left hand side is the same, but right hand side we have to resume from the last used location. So let me do a line break here, so it's a little bit tidier because I use a relatively big font size, and I think it probably exceeded 80 columns, so a break is needed. So yeah, so we, instead of starting from 0 as previous version, we're gonna resume from the last used location. And here this line is the same. Instead of the flag is also moved up there. Yeah, so we updated the number of read and the current characters used on in our own buffer. So that's just one extra update here, required for resume for the consecutive read call. Yeah, so that's pretty much it. Even though it's a hard level, it's hardly any different from the easier read question. All right, so let's run this. Okay. Do a quick check. Let me align it a little bit better. Yeah, looks good. All right, so there you have it. So this is the series of question, read 4. It's disliked a lot. This one even more. But it's not bad. The question has its peppers, and the solution is not difficult. It's just it's too much text, I guess. All right, so yeah, that's it for today.